Hello everyone. Today we are looking at one of the most powerful visual tools in a risk manager's toolkit, decision tree analysis. Formally, this is a diagramming and calculation technique for evaluating several alternatives under uncertainty by calculating the expected monetary value of each available path through the project. In plain English, this is the roadmap of choice. It helps you look at a fork in the road and figure out which way is safer and cheaper before you ever take a step. I remember a project where we had to choose between upgrading our old software or buying a brand new system. Everyone was arguing based on feelings, but once we drew the decision tree, the math showed that upgrading was actually a trap because the risk of failure was so high. By using these trees, you stop guessing and start calculating your future. So now that we have mastered the idea that a decision tree is a visual map for our choices, you might be wondering what the actual parts of this tree look like. Well, that brings us right into our next step, which is nodes and branches. This brings us to the anatomy of a decision tree. The technical books describe this as a structure consisting of decision nodes, usually shown as squares, where a choice is made, and chance nodes, shown as circles, where uncertainty exists. To put it simply, squares mean you decide and circles mean fate decides. Stay with me here, because you've probably seen this at the office. A square node is you choosing to hire a new contractor. A circle node is the 20% chance that the contractor might be late. Let's look at a dummy story. Imagine you are deciding whether to host an event indoors or outdoors. The square is your choice. The circle is a 30% chance of rain. By separating your choices from the things you can't control, you identify exactly where the risk enters your plan. Now, while knowing the symbols is a great start, we need to put some numbers on those branches to see which path is the winner, which leads us straight into the world of assigning probabilities and costs. Now we have to tackle assigning values to branches. Formally, this involves assigning a monetary cost or gain to each path and a percentage probability to each outcome of a chance node, ensuring the total probabilities for each node equal 100%. In everyday speak, this is putting a price tag on the maybe. For every branch on your tree, you need two things: how much it costs and how likely it is to happen. For example, if you choose the outdoor path for your party, it costs $1,000. But then you add the chance branches, a 70% chance of sunshine, $0 extra cost, and a 30% chance of a storm, which costs $2,000 for emergency tents. I once worked on a project where we realized a cheap vendor was actually more expensive once we added the 50% chance of them failing a quality test. By assigning these values, you create a realistic financial picture of each choice. But here is the catch. How do we boil all these percentages and dollars down into one number? That brings us right into our next step: calculating expected monetary value at the node. This brings us to solving the tree using EMV. The book style definition refers to the process of folding back the tree from right to left, multiplying the impact of each outcome by its probability and summing them up to find the expected monetary value for each decision path. To translate that into human speak, it's doing the risk math. You start at the end of the branches and work your way back to the start. If you have a 30% chance of a $2,000 tent cost, that chance node is worth $600. You add that to your $1,000 base cost, and now you know the real price of the outdoor option is $1,600. You've probably seen this. People only look at the $1,000 and think it's the best deal, but the math tells a different story. As risk management professionals, we use this to find the hidden costs of every decision. Now, once we have the numbers for every path, we need to actually make a choice and defend it, which leads us to path comparison and selection. Let's look at selecting the optimal path. Technically, this is the final step where you compare the EMV of each decision branch and select the one that offers the greatest value or the lowest expected cost, aligned with the organization's risk appetite. In simple terms, this is choosing the smartest bet. You look at path A and path B, and a tree practically shouts the answer at you. I remember a project where the build option had an EMV of $50,000 and the buy option had an EMV of $70,000. Even though buy felt safer, the math proved that build was the better business move because the risks were manageable. By comparing these paths, you identify the most logical direction for your project. Now, while having the math is a massive win, we need to show this logic to our stakeholders so they feel confident in our plan, which leads us right into our final step.